Okay. Welcome everyone to this month's MindSpore TSC meeting. So as usual, antitrust policy. I don't need to read it again. And some useful information. I think you already got that. I will skip the roll call. So as usual, we maintain all the meeting-related minutes, including slides, on GitHub as well as Gitty. So I think I will provide the minutes for the meeting last week, last month later, but our recording is up on YouTube already. So feel free to check it out. So just quickly, some community progress update. So for between our last meeting and now, we had one important public public speaking. That's the KubeCon China Summit. So lucky enough, we gained a keynote speech session. So I will send out the keynote, the recording link. If you're interested, you can check out later. We have organized our third study camp. It's an online study camp organized via WeChat groups. And we published a lot of technical papers. Unfortunately, in Chinese. I will try to have those translate as soon as possible. And but as you can see, our team has written like introduction on various subjects, like our autokernel generation, which we introduced, I think, May. Our white and deep for recommendation scenarios, the mass model, ResNet 50, and FastRCN. Okay, so this is just showcase of our certificate for the online study camp, some gifts we sent out. And we also kicked off the MindSpore study group, which I introduced in the previous TSC meeting. So given the COVID-19 situation, we try to maintain the gathering to a small crowd, which is much easier for people to exchange their ideas. We have organized MSG in about 4 cities in China, Shenzhen, Hangzhou, Suzhou, and Shanghai. So all are major cities, and we have invited speakers to do presentations. Okay. So StarFork Watch, we're still on a steady growth. As you can see, our download, our total download has reached more than 30,000, which is pretty remarkable. This is including our binary, the Git clones, the PyP downloads, and the Docker image. So this is our website visit, and we have provided a lot of tutorials and promo videos for our new releases. So our media viewership is also on an increase. One of the green news is shared by Dr. Xiao. The integration between MindSpore and Gina is officially done, I think.
Yes.
Yeah.
So,
can you?
So I can add something. So this takes quite a while. So first of all, because we are waiting on the match through, right? So second thing is we are trying to also do some refactoring on our end to better support all this framework, uh, this kind of deep learning universal framework, right? So after this two pre-step is done, and we are able to very proceed on this issue very quickly. So right now we have by referencing the what has been written in the match through AlexNet example, MindSpore on AlexNet, and we are able to build an example based on that and using this AlexNet for image search with Gina. And and we also but during the development we found that there is one thing that slows us down is that MindSpore do not have a mic support, right? So because we are actually using Mac OS for development, right? And it is very hard to find a mic uh, pre-compiled Python whales on Mac.
Okay.
Right? So I try to compile it by myself, but it's not very trivial. It's not very trivial. So you have to
Okay.
really look at the logs, look at all the CMake, these things, and so this kind of slows us down. So in the end, we found out there is a plugin, and we're basically using Docker and using Ubuntu image and wrap that in a Docker container, and then using a plugin in PyCharm to
Yeah.
interactively do the debugging, right? And so this is how we. I mean, this is a lessons learned in the development procedure. And yeah, but in the end, we managed to make it. So to wrap this up, so I will publish a blog post uh, to to summarize what we have learned and especially this debugging developing procedure with MindSpore. And I believe this is very interesting. And so I will share this blog post in probably in 2 weeks.
Okay. Thank you so much. And yeah, I think this might be the first like major open source integration with MindSpore. Yeah, very exciting. And okay, let's move forward. So for today's meeting, we have 2 new SIGs proposed and 2 working groups, all of which are like covering very interesting areas. So we have MSLite. So our like major update to the mobile and IoT side of MindSpore. We have the deep probabilistic programming support, and also we have a working group for molecular modeling. It's from the Shenzhen Bay Laboratory, which is another really interesting use case. And also we propose to establish a research working group. So I think let's go through the proposal one by one. Do we have folks for MSLite? Okay, I guess not. I think I can talk it through. So, by the way, all the SIG proposal we maintain it through the MindSpore enhancement proposal, so that everybody knows exactly what the motivations are, what their goals, and what they try to achieve. Okay, so this new SIG aims to start or pioneer the development basically for MindSpore on mobile and also IoT devices. Think of TF-Lite, right? So the goals are we want to support MindSpore models as well as some mainstream like TF-Lite models, Cafe models, and also Onyx models. So high performance because mobile and IoT devices are power sensitive. So you need a really performant framework to do that. So operating system wise, we need to support like Harmony OS from Huawei or the typical Android and iOS, the two major operating systems for mobile. And of course, lightweight. For the operator parsers, the MSLite team or the SIG will be responsible for development of the parsers for MindSpore, TF-Lite, Cafe, and Onyx, and support some very common neural networks. And the performance, including support the quantization, including post-training quantization. So MindSpore itself already support the training-aware quantization. I think in our last release. So lightweight MindSpore itself, if you can recall, we have the concept of the global high-level, the graph high-level optimization, low-level optimization. So it's similar for MSLite. So the runtime is only about 800 kilobyte, and we have an even smaller one. Yeah. Okay, this is the architecture. Let me see if I can. Yeah, so we have the front end, very similar to our main framework. We have the IR level. We have the backend for all the optimization, and then is the runtime, the RT, dealing with specific mobile and IoT hardwares. Testing is pretty typical, unit test, system testing, and so support post-training quantization, already mentioned, will support ARM CPU and Mali GPU, and also Kirin NPU from Huawei. So MSI does not support on-device training yet. I doubt there's a huge scenario for that, but anyways, the team seems like the idea. Okay, this is the first new SIG proposal. By the way, the Lite, a major version bump of the MSLite will be released by the end of this month. So in our upcoming release, we'll see the first like the first major update to the Lite. Okay. Second one is deep probabilistic programming. Jianfei, are you able to talk us through?
Yes.
Okay.
Can I share my screen?
Sure. Let me stop.
Okay. Can you see my screen?
Yep.
Okay. So I'll talk about our proposal about deep probabilistic programming. So here's some motivation. Why do we want to do the task of deep probabilistic programming? In the deep learning era, why are probabilistic models useful? At least three motivations. The first is the learning with limited labels. So up to now, we see most advance in the field of deep learning is due to supervise the deep learning, particularly like using the heavily labeled ImageNet dataset. However, this approach is kind of task specific. It's difficult to transfer to a new domain. Say if you have a new type of data like fMRI data, it's difficult to transfer, and you need to label the data again. And this approach cannot leverage unlabeled data, which are much cheaper than labeled data. And it also overfit. It's not robust to adversarial attacks. And particularly, data might be very expensive to collect in some cases, particularly in like reinforcement learning. And so in recent years, particularly this year, the unsupervised learning and probabilistic machine learning has made significant advance in learning with limited labels. Probabilistic machine learning provide a natural framework for unsupervised learning. So we directly learn a generative model of the unlabeled data. For example, we learn to generate images and text. And there is a common folklore in the machine learning community saying that to understand the data, you need to learn how to generate the data. So these arguments kind of argues why a generative model feature is useful to for general representation. And in recent years, the generative model features actually performs pretty good. In the natural language processing domain, we already have powerful models like BERT and GPT-3. They are all autoregressive generative models. And in the image domain, we now have something like Image GPT, which performs on par with the state-of-the-art self-supervised learning approaches, and even outperforming fully supervised learning on the same ImageNet dataset. And plus, it also have excellent capacity to generate data like this. This is imputation result of Image GPT. So the second motivation is uncertainty estimation. Uncertainty estimation is quite important for the critical tasks like autonomous driving and like medical images where we want to diagnose the disease. And it's quite important that a model can give you correct uncertainty estimation. Otherwise, we consider it to be not trustable or not safe. But currently, the modern deep neural networks like ResNet are actually give heavily overconfident estimation. If you here's a typical way to look at it. So you compare the confidence outputted by the network versus the actual chance of the classifier to be correct. You'll find actually these models are giving highly overconfident predictions. This is undesirable. And in contrast, in recent years, probabilistic machine learning approaches like joint energy model or some joint generative and discriminative models can give you much better uncertainty estimation. And the third motivation is the capacity to generate itself. And as we've seen, there are some new applications of generative models, such as still transfer, then data generation, and news report generation, and like face editing and movie editing. Okay, so all of the applications need the support of deep probabilistic programming. So by deep probabilistic programming, we mean the two things. First is a modeling language to define probabilistic models, and the second is an algorithmic framework to automatically solve probabilistic inference problems. As an analogy to the to traditional neural networks, so the modeling language is like the basic building blocks, layers and distributions, and the algorithm is like an analogy of SGD in the deep learning field. Now we have like convolutional inference and markov chain multicolor algorithms for probabilistic programs. And the base of our C group is the work of Zhu Suan, which was a open source package for deep probabilistic programming developed by Tsinghua University, and the major group of developers is now in this group now, and we want to port this Zhu Suan library to MindSpore and also customize some higher level APIs for like perhaps less experienced users, making it more easier to use. So in the end, we expect some built-in support for the deep probabilistic programming to MindSpore.
Could I just cut in? This is very, very interesting, and I'm impressed that you're going ahead with this, and this is very exciting. Mm-hmm. I'm not familiar with Zhu Suan as a framework for probabilistic programming. I'm sure it's very good. Is it? Are there other frameworks that it's quite close to? What would you say is the kind of nearest neighbor match in terms of the kind of most common, at least in the West, probabilistic programming frameworks?
Yeah, Zhu Suan is one of the earliest frameworks available for deep probabilistic programming, and our framework is developed roughly the same time with the Edward framework. So right. Zhu Suan and Edward are pretty same, and and then the group of Edward people develops the TensorFlow probability library, and the TensorFlow probability is also quite close to Zhu Suan, and actually they bought some design from Zhu Suan.
Great.
Yeah.
Thank you very much.
Yeah, thanks for the question. Yeah, and here's our C group members. The members are primarily come from Tsinghua University, the original development group for Zhu Suan, and also many people from Huawei Research, and we are developing this thing jointly. And here's our overview of our framework, the layers. So on the topmost is the toolbox layer, where we directly give some representative model and applications to the users, such as uncertainty estimation, out of distribution detection, and learning with limited label, and also generating models. And in this layer, we build the models using the framework we build in the lower layers, and we want these layers to this toolbox to be ready to use and require no background knowledge about probabilistic programming. So and on the slightly lower layer, we have a modeling layer which provides some high-level building blocks for deep probabilistic models, such as the invertible or autoregressive layers for building like autoregressive generative models, and also Bayesian neural network layers used for like uncertainty estimation. And also we want to provide converters from the traditional deep neural network to Bayesian neural network, which is transparent to beginner users. And as a core of this this project is a framework layer, which is the modeling language and the inference algorithm we talked before. For the modeling language, we have a modeling language for Bayesian network plus invertible probabilistic transformations. The Bayesian network is just like the traditional neural networks, but now the nodes, the tensors can be random variables instead of just deterministic ones. And we can query the probabilistic, the densities and request sample of the Bayesian neural network arbitrarily. And for the inference algorithm, they handle the probabilistic questions like what is the maximum likelihood solution and what are the posterior distributions. They handle these questions automatically by some black box algorithms, including variational inference and Markov chain Monte Carlo. And
another question. Do you know whether the variational inference includes expectation propagation as part of that?
In the first version, we will primarily focus on variational inference family methods, such as stochastic variational inference and reinforced. Yeah.
Thank you.
Yeah. And at the bottommost is a distribution layer, including the essential probabilistic distributions and kernels. Yeah, and I just copy paste these slides from the current version of Zhu Science tutorial. This is shed some light on how do people use this framework directly. I mean the framework layer, not the toolbox layer. So so people can build Bayesian nets like this. They make in their code, they make a fields of these definition of distributions and the deterministic transformations using neural networks. And you can apply some transformation to a random variable, and then you can still define Bayesian network and query the probability. Yeah, and here's the modeling language. And for variational inference, you need to build some variational distributions for the algorithm to use, which is again a Bayesian network. So you just use the same modeling language, and we do plan to include some tools for automatic variational distribution generation in the future. Yeah, but it's kind of a longer term goal. And then you use some inference algorithms to construct the variational inference objective and convert the problem again into a optimization problem. And finally, you still run gradient descent as usual. And yeah, here's our current version. Yeah, we have already developed a large fraction of the framework with colleagues from Huawei. And on the toolbox layer, we now have uncertainty estimation APIs for classification and regression. And I think we have a variational autoencoder model and also some basic Bayesian neural network model now. And for the inference algorithm, we now have the elbow estimator and the stochastic variational inference, and also a customized estimator for variational autoencoder, and also some, I think this should be in the layers. So we now have some layers for Bayesian neural networks. And also we have some basic univariate and multivariate distributions as well as bijectors. And we have kernels, I think, on both GPU and Ascend. Yeah, and I'll skip these details. And in the next version, we will focus on the framework part to include the general Bayesian network primitive as well as general proposed stochastic variational inference algorithm with reparameterization trick. And we will implement a example variational autoencoder model in an end-to-end way, just using our framework APIs. Yeah, and yeah, here's my proposal. Thanks.
Thank you. That's very exciting to have that added in to MindSpore. That's wonderful.
Thank you. If none of you have questions, I'll stop my sharing.
Okay. You can always follow up offline. Do we have any like follow-up questions?
So can I ask one question? So, so the deep probabilistic programming support. So, will that be kind of a separate project or a separate repository, or will it be part of the main MindSpore repository? So, how will that be managed?
We currently put our project in the core MindSpore library under the path of mindspore.nn.probabilistic, I think. The main reason of that is due to the rapid changing MindSpore APIs, and we want our library to be useful.
Yeah, I think this is exactly the right strategy. This is also
Yeah.
what I would have suggested. Yeah, thank you.
Yeah, thank you.
Yeah, I agree. I think integration makes a big difference in these sorts of settings.
Okay. Thank you, Jianfei, very much. So the new DPP SIG will be lead from the Tsinghua University team. So the third one, another interesting proposal is from the Shenzhen Bay Laboratory, the team working on molecular dynamics, actually. So I'll speak on behalf of the authors from the Shenzhen Bay Lab. So this is a new working group proposal for the molecular modeling. So I'm definitely a amateur and layman to this field, so I will try to explain as much as I can understand. So for things like vaccine development or discovering new materials, the fundamental research has to rely on the molecular level of modeling and simulation. So most of their research focusing on like predicting how the molecular will composite, you know, how the energy will flow from like one position to another. So for molecular modeling, for that field, they have been looking at deep learning for quite some time. So basically, they adopt like two ways: a descriptor-based model and a GN-based model. So, but for anyway, they face a really big hurdle because the computation complexity required for the molecular simulation and modeling is huge, really on a different level. So the Shenzhen Bay team told us that not to mention the modeling. So even if they want to build a model from ground up and they want to have a data set, say from ground up, the labeling alone is expensive and very time consuming. They tried to label even, I think, one tiny data in their data set, and they use like 3 months. So they basically just give it up and use pre-trained models. So that's why they are looking at MindSpore, because they tried TensorFlow, they tried PyTorch. So all of the current frameworks does not support the high order computation that well. MindSpore already provide a really great second order optimization, which we actually can provide a positive gain for the second order computation. So they are looking at using MindSpore for even more higher order computations. And so the purpose or the goal of this working group is to, first of all, the Shenzhen Bay team already provides several very specific technical requirements to the respective SIGs. So if we have this working group set up, we can have a more formal way of gathering requirements and feedback to the SIGs per release cycle. So we know each cycle we implement how much requirement that can support MindSpore to be used for molecular modeling or any scientific computing tasks. So the second goal is to provide a really nice documentation on for this scenario. And the third one is, so the team mentioned that, for example, JAX, which is like internal computation to TensorFlow from Google Brain. JAX has a plugin or library called JAX-MD, actually just developed for solving this particular problem. PyTorch has also a library for all the graph-based data structure. So probably this working group could also incubate a SIG if necessary, specifically for developing any libraries or modules that we need. And also we will run this proposal by TSC. The non-goals is that we won't develop a full stack molecular modeling software. It's out of our scope. We only focus on the MindSpore support for such task. So I basically copy out this text and figure from, there's a paper. If you're interested, you can just go over to, this is a nice survey paper for deep learning's application in molecular modeling and simulation. It's quite extensive and also very, very interesting. Hopefully we can sometime invite the working group leads over to have a seminar if they want to dive more in detail of all the molecular dynamics stuff. It's quite interesting.
Yeah,
okay.
Thank you.
Yeah.
I'm fairly familiar and work with a number of molecular dynamics people in the work I do. So again, I think this is also very exciting.
Yeah,
lots of exciting developments. And what would be interesting to, so I understand the not wanting to develop a full stack. I think you're right that that's out of scope for the MindSpore team itself. But one might hope that it supports that implementation. And I think, you know, as this develops, then encouraging a third party to take on that full stack implementation is probably quite an important part of getting this used in that context.
Oh, definitely. Okay, the last proposal is to propose to establish a research working group. So the research working group will be a place to like solicit input from a broader industry and the research community for several topics. So we gathered about 10 topics. Hopefully, if you know, any team is interested, we can collaborate within the research working group. So like the tensor differentiable computing framework and distributed parallel AI computing, I think these two are somehow related. Although MindSpore already you know, to some extent support a nice auto parallel, but still we need like innovation and new ideas to really make MindSpore run on a huge or large scale models or clusters. So performance optimization topics like low bit neural network, for example, binary, ternary, those could be used in really like low power IoT or like personal area network device. So memory optimization, also another big topic on the performance optimization side. Security, one of the area we're looking at is like a verifiable, trustworthy AI. I think this composite on several level. Maybe we are looking at like formally verifiable AI. It's math on math. If we can formally like do a formal verification for AI, which could be a really interesting topic. Another one is confidential AI computing. I think this also cross several layers. So for on the application layer, it's about like doing encryption stuff already we do for federated learning. And also on the much lower level, we might looking at taking advantage of technologies like the TEs, those enclave-based what we call the trust computing, those techniques. Maybe we are looking at a combination across a lot of stacks. So explainable AI and model optimization. So of course we want to understand AI as a whole. We don't want to be a black box forever. And also automatic model optimization. Also several topics on the model innovation, like You have deep probability model innovation, graph neural networks. Say we can support trillion distributed graph data storage, segmentation, sampling. So another one is AI for scientific computing. One example is we just saw for molecular dynamics or that type of scientific tasks. Yeah, so those were the topic that we propose. If you have other ideas come to mind, feel free to propose to the working group. But more importantly, please help spread the word and see if any team is interested in the idea, is actually working on the idea, looking for collaboration with deep learning frameworks. The MindSpore Research Working Group will be a place for such collaboration to happen. Okay. Okay. So that completes the bulk of our today's task. So as usual, I will do a release plan preview. I've already sent out the release plan in the beginning of the month, I think. So let's just quickly. So for this month, we'll be shipping Mask RCN, Tinybird, SNet, Inception V3, finally, for the Ascend 910 hardware. We also deliver MindSpore Hub. MindSpore Hub is it's the hub for pre-trained model. So before that, our model zoo is like composed with the scripts. Basically, it's not pre-trained model. So we will provide the MindSpore Hub for all the pre-trained model that we can use the legally okay data set with. Okay, several enhancement for the front end for the mind expression side. One of the major addition which Jianfei just mentioned is the deep DPP module support integration. And this month's release also will see a burst of the GPU model support. The team has been busy on shipping more GPU models, so people can use the GPU hardware to try MindSpore more conveniently. So for like distributed cluster to run wide and deep, we can already support that by the end of the month. And for CPU, we'll ship MobileNet V2. Another big chunk of the new release will be the MindSpore I just mentioned. So this will be the first major feature bump since our first open source version, which already come with a Lite component. So with this one, basically we open source the thing that powers the ML kit running on the any of the Huawei phones for the HMS service. This is quite exciting. Okay, we open up a lot of things. Okay, that'll be the end of the item I have. I still have several debt to pay. A translation of several Chinese articles. This is from last meeting as well. And the conference I've always tried to pack up with a good conference schedule. I will try to do it as soon as possible. Okay. Any other topic?
Can I ask a question about the research working group? So the research working group, so it'll essentially solicit proposals and then support particular proposals. Is that the idea, or so can you explain that part in a bit more detail?
Yeah. So the research working group is mostly like a organization within the community that, for example, if there's a team from a university interested in developing something related to the say trust computing for AI. So the team could reach out to the research working group. So for the research working group, for folks in the research working group, they will be like help gathering all the necessary informations and linking up all the right SIG team that could help either implement some of the features that can be implemented in MindSpore, or help align with the team that do the joint development. So before that, before we have a research working group, we can only do this type of collaboration like on a point-to-point level. Like if there's a professor working with Huawei, then maybe so it's more like company level. We really want there's a research collaboration happening on the community level. So this is essentially what the research working group is proposed for.
I see. Yeah, that makes sense to me. So the projects that are then ongoing, how will they interact with the rest of the MindSpore projects? Is there a process for them to kind of report back, or how will that relationship be managed?
If they are still like independent team now joining the MindSpore community, so all the interaction theoretically will happen within the research working group. So they can have joint meetings, we'll document any of the discussion output or action items, any of the work output. So all the collaboration, or the output of the collaboration will be within the research working group. And this is the research working group will also serve as a liaison between the team that is interested in one of the topics and the MindSpore development team from certain SIG or several SIGs. Yeah, so that's the gist of the idea. Yeah.
Yeah, that makes sense to me. Yeah, thank you.
And also there's no NDA, so any of the work here is ready to be public. So okay. Any other questions or topics?
One thing, maybe the people should have some information how they can contact the research groups. So do we leave some contact?
Oh yeah, we
emails or whatever.
Yeah, we didn't have time to complete the
that's
MEP.
Very important. Yeah, that's important things.
So our team will complete a like MEP for the research working group, so you can see the authors. We will provide the email information in the description. And so I think later on we'll put it in the working group in the working group folder. Yeah, sort of like a README file for the research working group, so everyone can find the contact information.
Cool.
Yeah.
Yeah, I think even going beyond that, it's quite important to promote that this mechanism of the research working group exists, right? Because obviously it's sort of a different way for research groups to interact with the MindSpore community. And I think just making, well, key groups aware of this will be very important.
Yeah. We'll try to, evangelize the idea. And also looking for your help to spread the good word. Okay, another heads up, just given our like really rapid and heavy construction of MindSpore, our monthly release, so we might be looking at a early 1.0 release targeting September. So let's see after the August release, if the SIGs are feeling confident to put out a 1.0, we will again, as usual, send out the 1.0 release plan earlier next month for the TSC to review. Okay, if there's no further question, we can conclude the meeting today. I will upload the recording to YouTube and various streaming site afterward. Okay.
Thank you.
Okay, thank you.
Thank you very much.
Thank you. Bye-bye.
Thanks, everybody.
you.
Bye.
Bye.